So hi guys, welcome back. So as we've been discussing about the dimensional analysis, so the different methods of dimensional analysis. So first we've been looking on the Rayleigh's method. So we have known about what is the steps involved in Rayleigh's method. So if you're not clear, you can go through the previous lecture. So and then you can come back to the problem. So here we have a sample problem which has been taken from a textbook. So the resisting force R of a supersonic plane during flight can be considered as a dependent variable. So we know what is the resisting force. It's the opposing force. So this opposing force of a supersonic plane during a flight depends upon the length of the aircraft. So because throughout the length the air will actually tends to flow, so that's why the resistance varies with respect to length of the aircraft, L, velocity V of an air viscosity mu, air density rho, and bulk modulus of air K. Express the functional relationship between the variables and resisting force. So now we're going to derive an expression functional relationship between the variables and the resisting force. So as we know that from Rayleigh's method, x dependent variable which depends on which is equal to functions of the other independent variables. So R will be equal to function of, write down all the independent variables like length, velocity, air viscosity mu, air density rho, and bulk modulus K. So this functional is been removed by introducing a constant, non-dimensional constant, can be any variable. So we can take K, A or B, anything, but we have to mention it's a non-dimensional constant. A into L power A, so these arbitrary constants, V power B, mu power C, rho power T, K power E. Okay, so 1, 2, 3, 4, 5. We got a 5 parameters. Okay, so substituting the powers on both sides of an equation. So actually we know that resisting is a force. For force we know force equals to, it's a function derived quantities, m L T power minus 2. So force instead of resist is a resisting force. For force we're going to substitute the dimensionless parameters. So m L T power minus 2. For length it's in terms of meters. So L, so A into L power A. V is velocity. For velocity we know L T power minus 1, which is meter per second. Okay, so while deriving and solving a problem, so we have to derive this before substituting these fundamental equations, derived quantities. So then for mu, it's the dynamic viscosity. So we know for dynamic viscosity it's mu equals to Newton meter per second, Newton second per meter square. That m L power minus 1 T power minus 1. If you substitute and derive, simplify it, you will get this m L power minus 1 T power minus 1. So instead of mu, we substitute m L power minus 1 T power minus 1 power C is arbitrary constant. Next, rho is a mass density, kilogram per meter cube. So kilogram mass m, meter cube it's in terms of length. So L power minus 3 because kilogram per meter cube. So denominator to the numerator, so minus 3. So m L power minus 3 into power d are the arbitrary constants. Next, K is a bulk modulus. So to know this bulk modulus, sorry, okay, I have not got this one. So if you know the bulk modulus will be m L power minus 1 T power minus 2 power E. Okay. So equating the powers of m, L, T on both sides of an equation. So now the next step will be equating these powers For first we're going to equate the powers of m. So left hand side, so m power 1, we have a 1, so 1 will be equal to on the right hand side, so it doesn't have any powers in arbitrary a, so b, then we have m in c, so m power c, so this c is being multiplied through this, okay, so c, then plus, because the powers are added, okay, so m power d, okay, so the powers of m will be d plus d, m power e, so plus e, so 1 will be equal to c plus d plus e, okay, so this is equation number 1. So then equating powers of l, so l power 1, so 1 is equal to a, so l power a, so a, l power b, so plus b, that doesn't have any negative sign, so plus b, then we have l power minus 1 into c, so minus c, l power minus c, so minus c, plus l power minus 3 into d minus 3d, so we have minus 3d and plus l power minus 1 into e, so minus c, so minus a, so 1 will be equal to a plus b minus c minus 3d minus a, so this is the powers of l. So next we're going to equate the powers of t. So on the left hand side we have a power of t power minus 2, so minus 2 will be equal to, so t power minus 1 into b, so minus b, t power minus 1 into c, so minus c, then t power minus 2 into e, minus 2e. Okay, so these are the powers of m, l, t we have equated. So now we're going to simplify. I'm going to find the values of a, b, c, d, e, then substitute on this equation. So that since the unknown are more than the number of equations, so the expressions a, b and c in terms of d and e. Okay, so since we have 5 unknowns, a, b, c, d, e are 5 unknowns, that is more than equations of 3. We have 3 equations alone. Okay, so m, l, t, so we have only 3 equations, m, l, t. So if it's so, then these 3 equations will have the fifth equation. 4 and 5 will be the variables that will be on the all these 3 equations. So b will be equal to 1 minus, so d will be equal to 1 minus c minus e, 1 minus c minus e. So b will be equal to, so here b will be equal to 2 minus c minus 2e, so this equation, so b will be equal to, so next a will be equal to this equation, a will be equal to, so all this 1 minus b plus c plus 3d plus e. So already we know the value of b and the value of d, so though both values b and d is known, so we're going to substitute the value of b here, so this into 2 minus c minus 2e, so instead of b we're going to substitute 2 minus c minus 2e plus c plus 3d, so we know the value of d, 1 minus c minus e, so substitute 3 into 1 minus c minus e plus e. So to simplify, so this becomes 2 minus c, so a will be equal to 2 minus c. So now we got the value of a, d and b. Okay, so substitute these values, a 2 power minus 2, a will be equal to 2 minus c, b will be equal to 2 minus c minus 2e, d equals 1 minus c minus e. So now I think you would have confused so much, so that's why we say Rayleigh's method is been limited only to 3 or 4 variables. So here we have 5 variables, right? 1, 2, 3, 4, 5 variables. So that's why I say if it goes more than 3 or 4, it becomes more laborious, so very difficult to equate the equation. Okay, so I'm just giving this example because saying that it's difficult for doing a dimensional analysis using Rayleigh's method when the parameters are more than 5. Okay, so we have Buckingham pi theorem, so it is a simplified version. So with any numbers we can do for Buckingham's pi theorem. Okay, so I'll again will come up with some problem, so where you will understand more clearly simplified problem. Okay, right. So now if you know the values of A is known, B is known, D is known, so C and E we're going to substitute directly C and E because we doesn't have the values for C and E. So R will be equal to, as we know, so on this equation R will be equal to A into L power A. So we know the value of A is 2 minus C, that's why we have C. A into L power 2 minus C. V power B, so B equal to 2 minus C minus 2E. So V power 2 minus C minus 2E. So mu power C, so C, you can see it doesn't have any value. Rho power D, for D we have 1 minus C minus E. K power E, so it doesn't have any equation for E, so K power E. So now what we're going to do is, so whatever the values in terms of minus, so that will be taken to the numerator. So here what are the plus values? So A L power 2, so A L power 2, V power 2, so rho L power minus C, V power minus C, mu power C, rho power minus C. So the C's and E's have been grouped. So these arbitrary constant values are grouped. So then the minus are being taken to the denominator. So A rho L power 2, V power 2, so the bracket. So mu, so these are C values. So values are C. Mu power C is a positive, so it is on the numerator. Rho power C, so rho power minus C, so it's on denominator rho. V power minus C, so V. L power minus C, so L. Rho V L is on the numerator. So mu by rho V L is a Reynolds number. Rho power C, so the arbitrary constant. Same way K by, so K is in terms of positive, K power E, so K by rho power minus E, so the rho is taken to the denominator. So V power minus 2E. So minus 2E, so we have taken rho by V squared, so whole power E. So this could be written as R will be equal to rho A rho L square V square. It's a function of mu by rho V L, K by rho V square. So we have taken this arbitrary constant and used this function. Okay, so this is a Rayleigh's method. I will come with another simplified example so to get much understanding. Okay, thank you guys.